नमस्कार, एक बार ऑडियो वीडियो चेक करेंगे. लेट अस चेक दिस ऑडियो वीडियो. Manish Verma, are you my regular student? Are you my regular student, Manish Verma? Okay. चलो, गुड मॉर्निंग. आवाज क्लियर है? चलो. Good morning everyone. Welcome to GATE Academy 2.0. So this is Sathish Kumar Dirshetty, Faculty of Measurements. So थोड़ा delay हो गया. So why? Because in our zone, in the morning zone, there is a queue in our area. Some containment curfew systems are happening. So in the early morning I have to go for the milk and I have to come back. So that's why I was delayed. So please try to understand. Sometimes this delay happens because the situations are not good at outside. Okay. So situations are not good outside. That's why we are in the morning. There are some works. So that's why I used to come 5 to 10 minutes delay. And this 5 to 10 minutes delay is not just to disrespect the students, it is also for the accumulation of the students. So the other students also can join. So we will be posting in the Telegram channel, we will be posting in other groups so that everybody can join in the class. Okay. So I hope, sir, how long will it take to complete the measurements course? Okay. Gomati, are you following my classes regularly? How long will it take to complete the measurement course? So see, regularly we are taking the classes on the measurements. So this is my lecture number 30. Still there may be 5 to 6 sessions. That means it may be around some 9 hours of course. Okay, it may be 9 hours of course will be there. Okay, it may be some 9 hours of course will be there. Okay, you started yesterday only, but because this is my 30th lecture, this is lecture number 30 actually. This is lecture number 29. This is lecture number 29. Okay. So my dear students, this is lecture number 29. We are discussing the energy meter. So in the last class we have discussed the energy meter. I think all of you understood the basic concepts of energy meter, right? Anand Bose, good morning. Anand Bose, how are you, man? How are you feeling? How was our yesterday's class? Microprocess class, how it was? Okay, you are from Tamil Nadu. Good morning, Alok Kumar. Good morning. How you are feeling my classes? Is every class is fine? Okay. Gomati, you please try to follow all my lectures. They are in the playlist, lecture number 1 to lecture number 3. I am going all the topics. Okay. Every topic I am discussing. Sir, take as much time as possible on this subject. We are not in hurry. Thank you, Ananja Bose. Thank you very much. Ananja Bose is a consistent student. Is my instrumentation student. Is a consistent student. So you have to understand the situations of the faculty also. My dear students, taking classes every day in the morning, okay, in the everyday morning 8 o'clock, it happens sometimes delay of 5 to 10 minutes, and you have to understand the present situation also, my dear students. You should not be that much easy to throw a comment on a faculty, and that to GATE Academy faculty. Okay, so we are giving the best content. When you are giving the best content, sometimes it happens to collect the information and to post on the digital board. Okay, it is not our regular classroom. In regular classroom, what happens? We have to take a paper and we have to explain the things. So in the morning itself, we have to go, and right now, you know, outside the situation is so panic. The COVID 2.2 second version chal raha hai. So we have to go outside and we have to bring. We are a family person, so you have to understand all these things, my dear students. Okay. Anyway, I am very sorry for the delay. I usually will be delayed for the class by 5 to 10 minutes. Okay. So 8:10, 8:13 in this duration the class will start. But this duration of delay is just to collect the students community and to just to post the information of the slides and all those things. How are you feeling, Anand Bose? Yesterday class was kaisa chal raha hai? Yesterday's microprocess. I am good, sir. How I'm good. Anand Bose. I'm so happy to ask. I'm so happy to get that question from you. Thank you very much. So good morning everyone. Once again, welcome back. So we are going a bit slow, but we are discussing all the content, mere doston. So you have to understand the struggle of each and every faculty of GATE Academy. Right now the GATE Academy 2.0 is facing a problem. Why? Because our videos are getting hacked. Our videos and our channels are getting hacked. So you know very well, sometimes we are delaying and we are making the channels, we are making our videos as private. The reason is You know, in the digital world everything can happen. Okay, chalo, we are discussing the energy meter. In energy meter, the first concept what we have discussed, the speed of revolution is proportional to the energy. So n is equal to k into E. So this k is the energy constant. So k is equal to n by E. So this n by E, what we can write? So we can write it as number of revolutions of disk, number of revolutions of disk in a time duration. This time can be expressed generally per hour. Generally it can be expressed in hour in a time. Okay, so E for energy consumed by the instrument in that time. So if you are doing this experiment for 1 hour time, if you are taking for 10 hours time, so like that it goes on happening. Oh, okay na? So this k is called as what? This k is called as energy constant. This k is called as energy meter constant. So units are revolutions per kilowatt hour. So what is this energy? This is the first point. This is the first point. Remember, all of you please maintain a short notes. All of you, whenever you are listening the classes, please maintain a short notes for each and every topic so that your time will be saved. Short notes. And the second most important point is, in energy meter, 1 unit means 1 kilowatt hour. 1 unit means 1 kilowatt hour. Okay na? So 2 units means 2 kilowatt hour. Like that you have to remember. And the next important point here is the errors in the energy meter. Okay na? Errors in the energy meter. All of you are able to listen? Gomati. In errors in the energy meter. So what are the errors in the energy meter? So yesterday we have discussed it. When you are discussing the errors in the energy meter, that you have to understand very clearly. So what is the errors in the energy meter? Try to understand errors in energy meter. The first thing is, we have to know the measurement true value of the power. Why? Because energy is equal to power into time. Am I right? Energy is equal to power into time. So power means generally what will take wattmeter reading. So this is possible with true wattmeter reading or measurement wattmeter reading. So what is this watt? Watt means VI cos phi na. So this is VI cos phi into time. So W true value is VI excuse me, this is cos phi into time, whereas measured value is, this will be VI sine of delta minus phi into T. Okay na, my dear student? So these are the two things. So you have to understand, this is what, this is an error due to, what I can write this as, this is an error due to phase error. Am I right? Error due to phase shift due to pressure coil current IP. Am I right or not? So last classes we have discussed. Once again I am giving the hint. So ideally this should be the picture. Okay na? So this should be the picture. This is the IP and this is our VP. So the angle must be 90 degrees. But practically what is happening? Practically this is happening. So this is our delta. So this is our IP. Okay na? So this is the measurement value. So error is equal to percentage error is equal to measurement value minus true value by true value into 100. So this is one error. This is one error. Okay na? So this is first error. All of you following, my dear students? So this is the first error. And the second error is, listen carefully. Listen carefully. What is the K value? K value is equal to N by E na, Ananja Bose. K is equal to N by E. N is proportional to E. Gomati following. Prajapati following. Yeah. Ananja Bose following. Prajapati, it is lecture number 29. Prajapati, it is lecture number 29. So we already started, 29 lectures are over. So within some 5 to 10 sessions, this course is also going to be helped. Okay. So K is equal to N by E. Listen carefully. So K true value क्या होता है? This N is equal to number of revolutions. Energy is equal to power into time. So this is N. Power means if you take VI cos phi, this is the ideal value. Am I right? VI cos phi into time. So this is time. power into time. Time let us take in small letters so that confusion will not be there. So this is a k true value. This is a k true value. There is another value for measurement value. So if you take the measurement value, what is the answer? This is n and y. So this is vi sine delta minus phi into t. So this is also one error or not? So this is an error in energy meter constant na. So error in energy meter constant. So error in energy meter constant. Error in energy meter constant. Error in energy meter constant is what? Measurement value minus true value. So that is kmv minus k true value. All of you understood mere dosto? So this is one more error mere dosto. So try to understand mere dosto. So this is one more error. Are you both following? So this is another error. So this is error number 2. This is error number 2 and this is error number 1. So this is error number 1. So this is error number 1. There are so many errors in the exam. There is a short questions are possible with related to these errors. Error due to the phase shift of the pressure coil. So this is a measurement value, this is a true value, and error in energy meter constant. Error in energy meter constant. So that is kmv minus k true value. Clear? All of you noted this point, my dear student? All of you noted this point, dear students? Gomati, Ananja Bose, are you noting? Alok Kumar, good morning. So this is second error. Clear have you? All of you understood? So these are the errors. There are so many errors. Let us discuss the errors first. See now, first, errors in energy meter. I have collected some theory information. So with respect to exams like IES, GENCO, SSC JE, Rajasthan Vidyut Nigam Limited, non-gate papers. So this type of theory questions can be asked. Theory questions. Errors in energy meter and their compensation. So first error is what? Phase error. That's what I have explained. It is necessary that the energy meter should give correct reading on all power factors, which is only possible when the field set up by the shunt magnet lags behind the applied voltage by 90 degrees. But the flux due to shunt magnet does not lag behind the applied voltage exactly by 90 degrees because of winding resistance and iron losses. Do you understand? On the boss, this is what again I am explaining. Ideally this should be like this, but practically what is happening? Practically we are having like this. So practically we are having like this. Again and again I am repeating this so that you can understand. So practically we are having like this. Okay. So this is our ideal. So this is our IP. So this is our phi p and this is our VP. Ideally it should be 90 degrees. But practically what is happening? So this is our IP. So this is our phi p. Ideal hona hai, but practically it is coming here. IP and phi p are coming here. Pressure coil, and this is our VPC pressure coil. All of you understood? So this angle is delta. The reason for this is what? This is most important. Anand boss, why I am giving again and again? In most of all the cases, phi will be considered as 90 degrees, sir. No. Most of all the cases is not considered under ideal condition only. Under ideal condition only, because the pressure coil is not purely inductive now. When pressure coil is purely inductive, if pressure coil is purely inductive, then only. But pressure coil is inductive as well as resistance na. Pressure coil is having some inductance effect and also resistance effect na. So because of the resistance effect is not 90, it is having certain phase angle delta. Clear? Pressure coil is not purely inductive. If it is purely inductive, then this is like this. If it is not purely inductive, this is like this. Clear, Anand boss? Doubt clarify ho gaya? So that's why I have mentioned here, dekho. But the flux due to shunt magnet does not lag behind the applied voltage exactly by 90. Very clearly I am using the words of because of what? Because of winding resistance. So this is most important. Because of winding resistance and iron losses. Clear mere doston? All of you clear? Are boss clear now? Yes. Pressure coil is series RL circuit. Yes. Pressure coil is like this. Why? Because we have to take like this now. So this is our current coil. So this is our pressure coil na mere dosto. Clear, Ananja Bose? Clear. So this is not purely inductive, it is having some resistance component also. Good morning. Good morning, Aman Tiwari. How are you, man? Are you following my classes? Are you following all my classes? Manish, are you following all my classes? Clear, Ananja Bose? Now shall I move? Gomati, shall I move to the next? Yeah. So what we are discussing, Ananja Bose, today's class we are discussing errors and their compensation. Now how to compensate this error? So we are having this error due to the lagging. So we have to, what we have to do now? We have to make this due to whatever the lag was happening, this delta. So to make the delta must be equal to 90 degrees, then what happens? This phasor diagram has to come like this. This phasor of this flux has to come like this now. That means this phasor of this flux has to come like this. That means what? The resistance effect has to be nullified. That is not possible. Mera dostam. Can you make the resistance of a coil as ideal practically zero? Can you make resistance of a coil practically zero? Aman Tiwari, very good. So can you make the resistance of an inductor practically zero? Aranja Bose, this is what my question to you. Can we make the resistance of a pressure coil is practically zero? Is it possible? So resistance effect decrease karna, is it possible? No. That's why what we have to do, as this is not possible, what we have to do, we have to increase this inductance. That means the inductance effect, the inductive nature has to be increased. Do you understand, my dostam? Inductive nature has to be increased. Is it clear, my dostam? Yes. No, it is not impossible. That's why we cannot reduce this resistance nature. Whenever for a pure inductor only it will come like this na. So if the coil is pure inductor, for a pure inductor only will get like this. But this is what inductance and resistance effect na. Inductance and resistance effect की वजह से ऐसा आ रहा है. So it should not be like this. It should be purely inductive. Purely inductive means what? You have to reduce the resistance effect. But resistance effect reduce is not possible. That's why you have to increase the inductance effect. So how we are going to increase that inductance effect? See this compensation. So what is the adjustment? Listen carefully. How the adjustment is going to be done? The flux in the shunt magnet can be made to lag behind the supply voltage by exactly 90 degrees by adjusting the position of shading band. All of you are able to see this picture. By adjusting the position of shading band placed around the lower part of the control limb of the shunt magnet. If you see the diagram, मेरे दोस्तों ध्यान से सुनिए. I have collected the diagram for you. एक second. So this is our energy meter diagram now. One second. So how we are doing this adjustment? Listen carefully. How the adjustment can be done? So we are using the shading bands here. So all of you are able to see the shading bands. So these are the shading bands, right? So this is the pressure coil. So this is our shading band. So if you see, this is a pressure shading band. So what we are going to do now? Listen carefully. So this copper shading band is there now. if you move this copper shading band towards upside, if you are moving this copper shading band towards upside, then what happens? The inductance effect is going to be increased na mere doston. Yes, Samantiwari, they have been hacked. Yes, Samantiwari, they have been hacked. All the content of sensors have been hacked. Our team is working on it. Our team is working on it. Our team is working on it. Okay, na? Our team is working on it. Okay, na? Is it clear? All the Gate Academy sensors classes have been hacked. Yes, yes, they have been hacked. Okay. Chalo, listen. Yes, yes, Aman Tiwari, all the classes have been hacked. Okay, all the sensors classes have been hacked. So they are going to come into picture in soon. Okay, so now if you see this, what I am doing, so this copper shading band has to be adjusted. So when you are moving this copper shading band to the top, listen carefully, my dear student. Dear my dear student. So this is already pressure coil. So this is our shunt magnet now. Listen carefully. This is our shunt magnet. To the shunt magnet, we are having the pressure coil like this. So to this pressure coil, some flux will be there now. Now what I am doing, I am attaching one more copper shading band. So this is our copper shading band. So this copper shading band, if you are moving towards this coil, then what happens? The net flux component is increasing. So this is a flux due to the pressure coil. This is a flux due to the copper shading band. Copper shading band. So the net flux increases. Net magnetic flux increases. When net magnetic flux increases, self-inductance is equal to N into phi by I. As the magnetic flux increases, inductive effect increases. Now this total particular pressure coil, is going to become pure inductive nature. It is coming closer to the pure inductive nature now. Close to pure inductive nature or not? Close to pure inductive nature or not, mere doston? So copper shading band will behave as an additional number of coil. They increase the inductance. So we have to move it. Ananja Bose, basically it will not be nearest, it will be away. Actually it will be not be nearest, it will be away. Try to understand. It will be away. When you move it towards it, then what happens? The inductance effect is going to be increased. Inductance effect is going to be increased. Is it clear, mere dosto? Inductance effect is going to be increased. That's what I have mentioned here. So that's why this understanding is important. So what I mentioned, see how the adjustment is done. The flux in the shunt magnet can be made to lag behind the supply voltage by exactly 90 degrees. So whenever you are increasing this inductance effect, slowly what happens? This angle will be changing now. This angle will become 90 degrees now. It will be coming to closest to 90 degrees. 100% 90 degrees is ideal. Making this is ideal, but closest to 90 degrees is possible. Yes or not? Is possible. All of you understood, my student? All of you understood, my dear student? Is it clear? So this is one error. So how many errors we are discussing? So first we have discussed error due to the pressure shift coil, error due to the phase shift of the pressure coil. So that is this, and how that can be adjusted we have already discussed. Up to now it is clear. Ananja Bose, up to now it is clear. So this is one error. There are so many errors in energy meter. So recent papers of IES, Genco, SSC, JEE, these questions are asked. So this is one error. Phase error is one error. Up to now it is clear. Chalo. Next I will go for the second error. The next error is speed error. So what is the speed error? Try to understand. How to adjust the speed? So speed error kaise adjust karna hai? Please note down all these things. One by one we are going with errors. Every error we are discussing. So what is speed error? Sometimes the speed of the meter is either fast or slow, resulting in the wrong recording of energy consumption. So an error in the speed of the meter when tested on a non-inductive load can be eliminated by correctly adjusting the position of the brake magnet. So movement of the brake magnet in the direction of the spindle will reduce. See, listen mere dosto. See, actually before this, I want to give an idea of frictional effect. I want to give an idea of frictional error. So listen this frictional error. First you have to understand the frictional error, then we will go to the speed error. Okay. So what is frictional error? You know very well, this is our aluminum disc, right? So this is our aluminum disc. So this aluminum disc has to rotate. That means there should be some deflection torque. So this deflection torque is going to come into the picture. Before deflection, every material is having some friction. There is a frictional force or not? So this deflection force, so torque due to deflection comes to the force due to the deflection. So this is a deflection force. So before torque, do you remember Anandabose, yesterday we have discussed torque is equal to force into something, distance. Okay na? So deflecting torque comes due to deflecting force. But this aluminum disc is made by certain material. So this material will be having certain mass. So wherever the mass is there, definitely there will be some friction. Na. So there will be some friction. So there will be some frictional force. Na. So your deflection force must be more than the frictional force. Na. Your deflecting force must be more than the frictional force. Then only this aluminum disc can rotate. Na. Am I right or not? So that's why we are using the lightweight. Aluminum disc. This instrument is not having frictional error only. All other instruments are also having frictional error. Every instrument is having frictional error. Okay na? The moving parts are definitely having some frictional error. So if you are expecting the deflection force, there should be some equivalent, your deflection force should overcome the frictional force. But here see what happens. Now if you see here, frictional error, why it happens? This error is introduced, try to understand. This error is introduced due to the friction at the rotor, bearing and resistor mechanism. So because this error is unwanted braking torque acts on the moving system and registers less energy than the actual energy. So how to adjust? This error can be compensated by placing two short circuited bonds on the outer limbs of the shunt magnet. So these bands embrace the flux into outer limbs of the shunt magnet and EMF induce circulating current through them. This causes phase displacement between the enclosed flux and the main flux. As a result of this, a small driving torque is exerted on the disc solely by pressure coil, which compensate the frictional torque. So this point you have to understand very clearly what is happening here. So if you see this diagram, so how to compensate this error? So whenever this frictional effect is there, your deflection force must be more than the frictional force. Okay. So that's why what I am using, aluminum disc. But aluminum disc is a lightweight. Na? Aluminum disc is a lightweight. So suppose my dear student, listen carefully. So if aluminum disc is lightweight, definitely what happens? Easily your deflection force will be more. When your deflection force will be more, then what happens? Deflecting force will be more, then the torque will be more, then the rotation is going to happen smoothly or not? The rotation is going to happen smoothly. Why? Because you have used aluminum disc lightweight. So because of the lightweight, what happens? The deflection torque is easily achieved. Deflection torque easily can overcome the frictional force. Then it easily rotates. So because of this, what happens? Too much of frictional compensation you are doing. So how you are doing the frictional compensation? If you are adjusting this weight to the low, then what happens? Your frictional force will be easily dominated by the deflection force, then more rotations are possible. And one more thing, this particular magnet, whatever is there, the braking magnet, this error is introduced due to the frictional at the rotor mechanism, because this error is unwanted braking torque acts on the moving system and registers less energy than the actual energy passing through it. So what happens? So whenever this is aluminum disc is lightweight, then what happens? We are having a magnet here, right? Braking magnet is there na, Ananda Bose. So this braking magnet, what it will do? So try to understand this braking magnet, what it will do? As it is a lightweight, it will be easily rotating. As it is easily rotating, then what happens here? This magnetic flux is going to induce. This magnetic flux is going to be induced here. So there is an induced EMF is going to act here. So this particular induced EMF is going to oppose this flux na. The main flux whatever is there. So this is going to oppose this flux. It acts like a brake or not. So this particular magnetic flux, whatever is cutting this aluminum disc, it induces certain EMF in it. So this induced EMF creates certain current in the aluminum disc. So this current in the aluminum disc is given by E by Z. Yesterday we have discussed. So this EMI is equal to E by Z. So this induced EMF is what? E is equal to N into d phi by dt. So this EMF is proportional to the speed of rotation. This EMF is also proportional to the flux. So if I write the common equation, you got E is equal to N into phi by phi m. So if you take this E out, you got some constant K1 into N into phi m. We got like this. Am I right or not? So current is equal to what now? Current is equal to K1 into N into phi by m by Z na. We got like this. Now dear students, listen carefully here what is going to happen. The light weight is happening. Suppose you have used the aluminum disc. Aluminum disc weight is light. Aluminum disc weight is light. Then the frictional force is light. Then the frictional force is right. So when the frictional force is less, the deflection force is more. When the deflection force is more, the speed of rotation will be more. When the speed of rotation will be more, then what happens? The induced current will be more. When the speed of rotation is more, the induced current will be more. This induced current creates some, this is eddy flux. Eddy flux is going to be created na. So this eddy flux is going to oppose the main flux na. This eddy flux is going to opposition of the main flux na. Opposition of the main flux is going to be increased. Then what happens? The brake is going to act. So more is the opposition, then what happens? More is the opposition, then what happens? The brake is going to happen. So because of that, what happens? The readings are automatically going to be reduced now. The speed is going to be automatically reduced or not? The speed is going to be reduced or not automatically? Do you understand? This is wrong na? Do you understand this logic? As you are using the aluminum disc, for the aluminum disc the frictional force is very less. Is it clear? Okay na? Dear students, as aluminum disc we are using, frictional forces will be less, reflection force will be more, then the speed of rotation will be more. When the speed of rotation is more, this current induced will be more. So when the eddy current is more, this is eddy current, this is induced current means eddy current. So this eddy current creates some eddy flux. So eddy flux, so this eddy flux will be opposing the main flux. So main opposition, what happens? Speed automatically reduces. So that's why what we have to do now to compensate this, what I am doing. If you see now current coil, so what we are going to do here. So here for this aluminum disc, so this aluminum disc at the edges we are introducing certain magnet. So we are introducing certain magnet. Listen carefully what he has given. So how it is going to work? How we are going to compensate? How we are going to compensate? See here. How we are going to compensate? This error is compensated by placing two short circuit bands on the outer limbs of the shunt magnet. These bands embrace the flux contained in two outer limbs of the shunt magnet and EMF induce circulating current through them. This causes phase displacement between the enclosed flux and the main flux. As a result of this, a small driving torque is exerted on the disc slowly by pressure coil, which compensate the frictional torque. That means what I am doing now, here this error is compensated by placing two short circuited bands on the outer limbs of the shunt magnet. So if you see this outer limbs of the shunt magnet, so on the outer limbs of the shunt magnet, So here we are introducing certain magnetic, so outer limbs of the shunt magnet, what we are doing. So now what we are doing, see on this aluminum disc at the edge we are having certain magnetic edge. So we are creating certain magnetic edge. When you are creating certain magnetic edge, then what happens? A net magnetic flux increases now. So you are losing certain magnetic flux because of this break. Because of this break here, the magnetic flux is reducing. So when you attach a small magnetic field here, so the net magnetic flux increases, so that the speed of rotation is going to be read correctly. The speed of rotation is read correctly. So this is another error. Next, let us go for the speed error. So how the speed error can be executed? See here, speed error. Sometimes the speed of the meter is either fast or slow, resulting in the wrong recording of the energy consumption. So when it is possible, dear students, listen carefully, listen carefully, listen carefully, listen carefully. If deflection torque is more than the frictional torque, generally, all of you listen carefully, when the deflection torque is more than the frictional torque, for example, you could have experience in our night times, so we say for the deflection torque must be more than the frictional force. That's why we are using the aluminum disc. So this aluminum disc is lightweight, that's fine, everything is fine. Listen Anjabos carefully. You have closed all the power sources, you have closed your fan, you have closed your room, you have closed your all power, you have switched off all the power, but in the night time you will use the bed lamp. So when you use the bed lamp, if you are using a small bed lamp, so this is a small bed lamp. So for this bed lamp also, the current passes through the current coil or not? So small current is passing through the current coil or not? Actually I am using the bed lamp. So for the bed lamp also, when all the power is off, main sources of load are off, main sources of load is off, motor off kiya, refrigerator off kiya, everything off. In the night time, what we will use? In the night time we will use a bed lamp. When a bed lamp is on, then what happens? Current passes the current coil. That can create the deflectional torque. That can create the deflectional torque or not, my dear students? Please answer me. That can create the deflectional torque. If this deflection torque is happening, if the frictional torque is very less, if the frictional torque is very less, the deflection torque is very high, then what happens? Automatically rotation will be increasing now. The small magnet, the edge of the disc will nullify the eddy flux. Yes, Sananya Bose. It will nullify the eddy flux. So this small magnet will nullify the eddy flux. That is over, already I told you. Okay, but what I am talking about, this speed error. All of you understood this speed error? So what is happening to the speed error? Listen carefully. When all the mains are off, a small bed lamp you are using, for a small bed lamp, a small current of milliamperes is going, then also deflection torque will be more now. So for the small deflection torque, but your frictional torque is very less. As you have used the aluminum disc, the frictional torque is very less. Then who is dominating? The deflection torque is dominating. So even for the small current, what happens? As the frictional force is almost zero, the deflection torque is very high, even for a small current, then what happens? The rotations will be, more rotations will be happening or not? More rotations will be happening or not? So even for small current, as the deflection torque is more dominating than the frictional torque, then what happens? The aluminum disc rotations will be increasing now. As the aluminum rotations will be increasing, then the reading will be increasing now. Reading of the meter will be increasing or not? When reading of the meter is increasing, the price of the current bill, the price of the bill is also going to be increasing now. So that means the whole night if you turn on the small bed lamp, then also you are going to get more meter bill or not? Yes or not? Do you understand this? Do you understand? This is the most important. That's why in our home you can observe this. The old energy meters, not the new energy meters. In our old energy meters, the old energy meters were like this. In the old energy meters, there was a circle like this, and there was a reading. Have you observed? There was a reading, it will be rotating like this. Have you observed? There was a reading, it will be rotating like this. There was a reading, it will be rotating like this. Have you observed? You could have seen in the old energy meters. In our villages, still we are using the old energy meters. So when you switch off all the things, and if you watch that energy meter line, nowadays nobody is using these old energy meters. In the old energy meters, there was a red line. Have you observed? There was a red line. The red line was rotating like this. The red line was rotating like this. You turn off all the lamps. You turn off all the motors. You turn off your TV, refrigerator, computer, and just turn on a small lamp and you watch it. Then also you can observe this. Yes. Yes. So this speed can be how it can be happening. So this speed has to be adjusted. So what we have to do now? The speed has to be controlled. So to control the speed, what I will use this braking magnet. So what I will do now, this braking magnet I will move front, or this braking magnet I will move forward, backward. Then what happens? See here, how the speed error can be reduced. So sometimes the speed of the meter is either fast or slow. Sometimes the meter is either speed or slow, which is giving a wrong recording. So to adjust this, what I am doing, an error in the speed of the meter when tested with a non-inductive load can be eliminated by correctly adjusting the position of the brake magnet. If the brake magnet is going direction of the spindle will reduce the brake torque and vice versa. How? Movement of the brake magnet in the direction of the spindle will reduce. How it will reduce? So this is our, listen carefully. So this is our aluminum disc. So this is our aluminum disc. So this is our spindle. So this is our spindle. And this is our brake magnet. I am taking the brake magnet like this. So if you try to understand this brake magnet, so this distance is R. This distance is R. If it is coming nearer, then what happens? N is inversely proportional to R. N is inversely proportional to R. If this braking magnet is coming nearest, then what happens? R reduces. When R reduces, N increases. If you want to reduce the speed, then what I will do, the braking magnet I will move towards the edge. So I won't keep here, I will move to the edge. So if braking magnet is moving towards the edge, if braking magnet is moving towards edge and entama anjapose towards edge of the disc. So this is the edge na. So this is the edge. This is the center. So if you are moving towards the edge, then the R is increasing or not? If the R is increasing, then the speed is going to be reduced. That's why this is important point. Edge bola to ye hai. If you are moving towards the edge, edge of the disc means away from the center. So this is the center of the disc and is away from the center. If you are moving like this, then R is increasing. When R is increasing, N is decreasing. That's why, have you watched? Whenever we are facing some problem in energy meter, we will call to the electricity people. सर हमारा घर में ऐसा हो रहा है, हमारे घर में पूरा लोड बंद है, रेफ्रिजरेटर बंद है, मोटर बंद है, एवरीथिंग बंद है सर, लेकिन एक स्मॉल 0 वाट बल्ब चल रहा है सर हमारे घर में, हमारा पूजा गदी है सर, हमारा डिवोशनल रूम है सर, हमारा बेडरूम है सर, उसमें एक स्मॉल लैंप जल रहा है सर, इस स्मॉल लैंप को भी हमारा मीटर इतना तेज से घूम रहा है सर, ऐसा कंप्लेंट करेंगे इलेक्ट्रिसिटी डिपार्टमेंट को. You will make a complaint to the electricity department, then the electricity department will send a technician, that lineman will come, the line will open the energy meter, he will adjust that braking magnet, then the speed of the disc is going to be very slow. समझ में आपको आनंद जबूस? So this is what happening. The technician will come and he will adjust this braking magnet distance. As a braking magnet distance is moved away from the center. Away from the center means what? Towards the edge. When it is moving towards the edge, what is happening? The gap increases. When the gap increases, the speed of rotation decreases. This already we have discussed. Do you remember? The braking magnet we have discussed already in the last class. in the last class we have discussed the braking magnet torque, brake torque is directly proportional to force into distance. The force is given as this is current and this is resistance. So this is this is distance. This is a distance. So I have removed this. I have taken this as constant k, some k phi m into I into r. So just before we have derived the expression for I. What is the expression for I, mere dosto? Just before we have discussed the expression for I. What is it I? So this is our I now. Somewhere I have discussed. Yes, this is our I. We have derived the expression for I. So this is our I now. I is equal to k1 into n phi m by z. I is equal to. So if you take this as k2, this is phi m. K1 into. We have discussed now. I is equal to E by Z. E is equal to K1 into N into phi by Z. Am I right or not? So if you substitute that here, K1 into N into phi by Z phi m into Z R. So if you see now, so this is a braking torque. So the braking torque is equal to K1 K2, that means K3. So this is phi m square. This is by Z and this is R. So if you see now, this is our TB, braking torque. This is our braking torque expression. Okay now? All of you clear about this? Braking torque expression. Last class we have derived this expression. So this is a braking torque expression. So deflection torque expression क्या है? Deflection torque expression is VI cos phi. Deflection torque is VI cos phi. So at steady state what should happen? At steady state deflection torque must be equal to braking torque. So deflection torque is equal to VI cos phi. VI cos phi must be equal to K3 into phi m square into R by Z. So this is power. If you multiply with the time, you are going to get energy. Vi cos phi into time is equal to energy. So this is Km into phi m square into T by R, Z by R. Okay na? So this is nothing but energy. Am I right or not, my dear student? So this is energy. So if you see this energy, so this is K3, this is phi m square, this is T by Z into R. All of you discussed now. So speed we have discussed already. Speed n is proportional to E. So n is equal to K into E. Am I right or not? All of you following? So this is all we have discussed. N is equal to K into E. Is it clear, mere dosto? Yeah. So yesterday we have discussed. It's absolutely clear. So definitely what is happening? So by reducing this particular gap, we can control the so that's what. Is it clear? All of you clear, mere dosto? All of you clear? Yesterday we have discussed. So by moving this away, okay. So this is what we call as speed errors. And the creeping error. What is the creeping error? So this is another one. What is this creeping error? So this is also one of the important point. Creeping error. Creep means what? Slow moving. That's what I have explained you. Just before I have explaining you creeping error. The slow but continuous rotation of energy meter, which only pressure coil is excited but no current flow through the current coil, is called creeping. So sometimes what happens? Suppose current is not passing through the current coil. But the pressure coil, when it happens, no. See, why we are using the shading bands? Dear students, listen carefully. Why we have used the shading bands? The shading bands are used for what? Pressure coil inductance के लिए ना, to make the pressure coil as purely inductive ना. Pressure coil purely inductive. Suppose too much of inductance we have done, too much of inductance we have done, what happens? The magnetic flux will be more, na? The magnetic flux will be more. So suppose in this situation the current is less, the current passing through the current coil is almost zero. The current passing through the current coil is almost zero. Ananja Bose, listen carefully. The current passing through the current coil is almost zero, but the shading band is adjusted so heavily. Because of too much of adjustment of the shading band, what happens? The inductance effect will be more, na? When the inductance effect is more, the pressure coil is purely inductive, na? When the pressure coil is purely inductive, it generates the parental flux, magnetic flux, the pressure coil flux will be more. So the pressure coil flux will be acting in one direction, but from the downside there is no current coil flux. Then what happens? The slow rotation is possible or not? All of you understood? Good morning, Chinay Sharma. So this is what I am saying. The slow but continuous rotation of energy meter, which only pressure coil is excited but no current flow through the current coil, is called creeping. This error may be due to excessive friction compensation, excessive voltage supply and stray magnetic field. So ज़्यादा frictional compensation किया आपने. So frictional compensation is also too much you have done. When frictional compensation you are too much in doing, then what happens? Then also it is going to be possible. Then how to adjust? All of you understood, my dear student? Is it clear? So how to adjust this? So to make the adjustment, the creeping is happening. That means when the current passing through the current coil is equal to 0, but the magnetic flux is very high for the pressure coil, then there is a pressure coil flux is acting one direction. The disc is going to rotate smoothly for a longer duration of time. So this is what we call as creeping. To reduce the creeping, what I am doing? So to reduce the creeping, what I am doing, see here, I am going to attach. So to reduce the creeping error, so there is an extra magnetic flux now. So what I am doing, two holes are drilled in the disc. So why? Because here the shunt magnet is like this. Listen carefully. थोड़ा patience होना चाहिए. So this is our shunt magnet now. So what you have done? So this is our pressure coil. So this is our aluminum disc. So this is our current. This is our voltage across the pressure coil. Okay na? This is a voltage across the pressure coil, and this is a current passing through the current coil. So this is a current passing through the current coil, and this is a load. So this is our U-shaped magnet. This is our U-shaped magnet. Listen carefully. So this is a diagram. Suppose this current is 0. This current is 0. There is no current passing through the current coil. But this shading band की वजह से this flux component is, flux in the pressure coil is too high. Flux in the pressure coil is too high. Why you have done the flux in the pressure coil? Due to the phase shift ఉండొచ్చు, or due to the frictional effect also. Due to the frictional effect, what you have done? To overcome this friction, you have given more magnetic flux. Then what happens? This magnetic flux will be acting here. Then there is a torque in one direction. So the torque in one direction, what it makes? The pressure coil flux is there, but the current coil flux is almost 0. Current coil flux is almost 0, but this flux is acting in one direction. There is a slow movement of this particular aluminum disc is happening. Do you understand? Ananya Bose, is it clear? Absolutely clear. Sharma ji, Ananya Bose, everybody, is it clear? So one side magnetic flux is more because of too much of frictional effect, too much of frictional compensation. आपने फ्रिक्शनल इफेक्ट को कंपनसेट करने के लिए एल्यूमिनियम डिस्क से आपका डिफ्लेक्शन फोर्स ज्यादा होना चाहिए. इसके लिए आपने क्या किया है? आपने फ्रिक्शनल इफेक्ट कंपनसेट करने के लिए आपने इंडक्टेंस इंट्रोड्यूस किया है. So when you are introducing the inductance, what happens? Then there is a small motion. So what happens now? Magnetic flux, extra magnetic flux is coming. Even though there is no current, but because of, flux on a coil never dies na, Ananja Bose. Flux on a coil never dies. Even though there is no current, but this particular coil is purely inductive because of the previous analysis. Ante paile you have turned on the system, some current was traveling, at that time you got some reading. Now you have switched off it. When you switched off it, the current is equal to 0. When current is equal to 0, this flux must be 0. But it is a pure inductor. प्योर इंडक्टर बन गया, इंडक्टेंस इफेक्ट ज्यादा हो गया, इंडक्टेंस ज्यादा हो गया, प्योर इंडक्टर के ऊपर फ्लक्स नेवर डाइज, so there will be a flux effect. Because of the flux effect this rotates. That's why what we are doing, to eliminate this, we are going to create certain holes on this. We are going to create certain holes on the aluminum disc. When you create certain holes on the aluminum disc, जो कुछ excess flux is there, that excess flux is going to be leaked out. The excess flux जो कुछ भी is there, so this excess flux is going to be leaked out through these holes. Interesting ना आनंद बोस. So through these holes the flux leaks. Through these holes this flux gets leaks. So जो कुछ extra flux है ना, that extra flux gets leaked out. So that is what happening, the creeping error compensation. So creeping error, how it will be compensated? Creeping error, why, first of all, why the creep comes? Why creep comes? Why creep comes first? Why creep comes first of all? Creep means what? Whenever the flux in the pressure coil is too high and flux in the current coil is very, very less, then definitely on the aluminum disc one side flux is more dominating. So because of that, even though there is no torque from this side, there is no torque from this side, but there is a torque acting from the upper side, then a slow movement is possible. So as the TD1 is dominating TD2, now what we have to do? We have to reduce this TD1. To reduce this TD1, what I am doing, we cannot reduce the TD1. We cannot reduce the TD1. Why? Because already that coil has become purely inductive. So what we have to do? We cannot reduce the TD1, but whatever the flux extra created due to this TD1, that can be reduced now. To reduce that flux, what I am doing? I am using the holes. So through these holes, that extra flux is going to be leaked out. That extra flux is going to be leaked out. Is it clear, मेरे दोस्तों? मजा आ गया? मजा आ गया? So these are the major important points. Anand, these are the major important points. Next one, common errors are there. There are common errors. Common errors. Temperature error. This is a common error. These are common errors. Temperature error is present in every instrument. The error due to the variation of temperature are very small because the various effects produced tend to neutralize one another. Next, the resistance of the disc of the potential coil and characteristics of magnetic circuit and the strength of the brake magnet are affected by the changes in temperature. That is a common thing. Therefore, great care is exercised. Great care is exercised in the design of the meter to eliminate the errors. You know very well. However the care you take, Anand, there will be some temperature effect will be there. Why? Because pressure coil you are using, current coil you are using, every coil is having some resistance effect, current coil is also having some internal resistance. So whenever the temperature is changing, definitely what happens, the temperature can affect the resistance of the coils. That's why while you are designing the coils itself, a great care must means what? Great care means what? We are going to use manganese. Great care means what? We are going to use manganese, constantan. We are going to use manganese or constantan wires. Manganese or constantan wires which are going to act like some swamping resistance. Which are going to act like some swamping resistance. So next one is frequency variations. What are the frequency variations? The meter is designed to give minimum error at a particular frequency, generally 50 Hz. So this is also an important point. Whenever frequency is changing, definitely the alternating flux characteristics also changes na, Anand Bose. For high frequency, we are having so many errors. For high frequency, eddy current errors will be more. The more is the frequency of the supply. When frequency of the supply is increasing, then what happens? Definitely flux frequency also increases. The meter is designed to give minimum error at a particular frequency of 50 Hz, generally 50 Hz. If the supply frequency changes, then the reactance of the coils also changes. Reactance of the coils also changes. When resulting in what happens? In a small error. Fortunately, this is not of much significance because commercial frequencies are held within closed limits. In India, we are using 50 Hz frequency. Next, voltage variations. Voltage variations also matters. The error due to variation in voltage is very small. This can be eliminated by the proper design of the magnetic circuit of the shunt magnet. Voltage can be varied. So this frequency variations, frequency must be 50 Hz. When frequency is 50 Hz, then the coil react, this is our pressure coil. So pressure coil is having omega L plus R. So this omega is 2 pi F into L plus R. But when the frequency is increasing, if the frequency is more than 50 Hz, then what happens? This reactance Z is going to be changed. When Z is going to be changed, the flux is going to be changed. When the flux is going to be changed, the current is going to be changed, the torque is going to be changed, everything is going to be changed. That's why commercial, most of all our energy meters are limited for a frequency of 50 Hz. For a frequency of 50 Hz. Is it clear, my doston? Is it clear, Anand Bose? Up to now it is clear, Anand Bose? Perfect. All the errors I have discussed. All the errors I have discussed. What are the errors? Error due to, all the errors I have discussed, no need to write. All the errors I have discussed. Error due to phase shift, error due to creeping, error due to the speed, frictional error. We have discussed the frictional error, and we have also discussed the speed error, and we have discussed the error due to the phase shift, error due to the phase shift. These are all the errors. Absolutely clear. So we discussed the phase error, we have discussed the adjustment. Next we have discussed the speed error, we have done the adjustment. Next we have discussed the frictional error, we have done the adjustment. Next we have used the creeping error. Creeping error, how it can be adjusted, that also we have seen. The temperature error we have seen. Yes, digital energy meter. No, we don't have digital energy meter in syllabus. Anand Bose, frequency variations. Okay. Okay, my dear student. So this is the end of this session. So today we have completed all the errors in energy meter. Errors in energy meter is the most expected question in competitive exams like ISRO, GENCO, IES papers. All the concepts are clear, mere doston. Is my all concepts are clear, Anand Bose? So please go through these slides once again. Okay. So tomorrow's class will discuss the next topic. Okay. All of you enjoyed the session. So today's class I have completely discussed the theory of errors in energy meter. Errors in energy meter. Errors in energy meter is most important. I have discussed all the errors. Error due to inductance effect, error due to speed, error due to creeping, error due to temperature, error due to frequency. These are the common errors. Okay. So each and every error and its adjustment we have discussed. So in the next class we will discuss some more points on energy meter, and if possible we will go for the next topic. Anand Bose, have you understood the topic? The topic is theoretical. Today's topic is theoretical, but it is an untapped content. Nowhere you can get this type of information. So all errors I have discussed. Each and every error I have discussed in detail. Why? Because generally students will get the content of just working and formula. Instrument working and formula, but I am focusing on all errors. We have discussed errors in PMMC, we have discussed. We have discussed errors in moving iron, we have discussed. We have discussed errors in dynamometer. So whenever you are discussing the measuring instruments, so PMMC is there, suppose the working formula we have to discuss, and next we have to discuss the merits and demerits, then next we have to discuss errors in instrument. So for PMMC we have discussed, for moving iron we have discussed, for dynamometer we have discussed, and for energy meter also we have discussed. इतना डिटेल में आपको डिस्कशन मिला आपको. चलो, thank you very much. We'll meet tomorrow. Love you all. Take care. Bye bye.